All right, welcome to section 2 for coordinate geometry. Today we're covering slopes. Now, slopes are super easy, so I'm going to go a little bit into background information on. We're just going to go a little more in depth than you've ever gone before, probably. So here's what we have. When we're doing slopes, we have y2 minus y1 over x2 minus x1. This is your common slope formula. Another way that you call it is rise over run. And then you have this last formula over here, which isn't used too much, but if you're going into upper math, it's nice to be familiar with it. This is pronounced delta y over delta x. Delta is one of your most common Greek letters that is used to describe change. This little triangle with a fat side on the right, it's called delta. It's used really often in physics. They'll say like, oh, what's the delta of this? How much did these numbers change? It's used in statistics. So it's good to be familiar with is all it is. But really it's just saying how much did my y change divided by how much did my x change, which comes out to y2 minus y1 over x2 minus x1. This is also labeled by the variable m. Now, there are different types of slopes. There's positive, negative, undefined, and zero. Please be careful. Positive slopes, it goes up, and it's because your number's positive. Negative slopes, it goes down. It's because your number's negative. Undefined slopes, the lines look vertical like this, and that's when you have a rise, but your run is zero. That means you're not allowed to move left or right, which is why your numbers go straight up and down like this. It's when you're dividing by zero, you get an undefined slope because anything divided by zero is undefined. Now, a zero slope is where you have nothing on top and you have a run. You can run all you like, but you're never going to see any improvement, which is much like how math relates to real life. Anyway, so basically, this is your zero slope here, and that means it's going to be flat because you're not allowed to go up or down. You're just moving left to right. Okay, please be careful. A lot of people screw up undefined and zero, but again, undefined is because we're not allowed to divide by zero, which means my number is undefined. Now, last video, I talked about colinear points and distance formula, and I said that it's super irritating to do it by distance formula, but it's possible. The better way to do it is if things are colinear, that means there's a consistent growth. And what we mean by consistent growth or a linear growth is that everything follows the same slope. So all points on your line have the same slope. So if you're trying to decide whether things are colinear, the best way to do it is say, hey, do they all have the same slope? That's one way that you can kind of check it. Now, please be careful because this isn't the perfect way to do it. The other way is better, but this is like a kind of quick shortcut method that you can use to kind of figure things out. All right, now, all right. So when we're dealing with slopes, slopes are basically all proportion problems. We're saying rise over run, and they're continual, not discrete. What that means is, let's say you're given something like this: y equals 3 over 2 x plus 1, and I asked you to graph this. And then you guys went up 1. Then from here you said we're rising 3 and we're running 2. And then this is my line over here. Now, what that means is we don't go rise 3, run 2, rise 3, run 2. And we don't only do that, and we don't only end up at these points. We also have points in between these over here. So we're not just saying, okay, rise 3, run 2, rise 3, run 2. We're saying that the proportion of rise to run should be 3 over 2. That means if I rise 3, I have to run 2. If I rise 6, I have to run the same proportion that gives me 3 over 2. If I rise 5, what's my new proportion going to be? That one's a little bit more difficult, which is why you need to use proportions. Now, the reason I'm bringing up continual versus discrete is, again, this is just more mathematical vocabulary that's helpful to know. Continual means that there exists a value for every x. Discrete means that you only take it at certain intervals. Like, for example, if you were looking at something like, oh, what was your weight at the end of every day? It could be something, your graph would look something like this. Oh, I was like 115 pounds, and then I ate a lot of food, so at the end of the day I was 120 pounds. Now, throughout the day, you don't magically jump. As time goes on, you kind of gain more weight, you lose more weight slowly, but you don't really care. You're only looking at the end of the day. That's discrete. Continual says, okay, let's look at this really closely. Again, just mathematical vocabulary, good to know. So if I give you a slope m equals 1, 4, one question that I could ask is, if y increases by 3, what does x increase by? Now, in this case, you know this is your change in y over change in x. So you know that if you increase by 1, you have to increase by 4. So if you increase y by 3, you have to increase x by 12. Now, the way you set that up is 1 over 4, that's your set proportion. That's your slope. But you know that you increased x by 3, so what, or y by 3, so what do you increase x by? So then you just solve the proportions. We have x equals 12 using cross multiplication. Done. Now, it's a little more difficult if I ask you this bottom one. If x increases by 3, what does y increase by? So we have 1 over 4 equals y over 3. So now we solve. 3 equals 4y using cross multiplication, and then we divide by 4 again. So it's 3 over 4 equals y. So again, we're not doing this nice little jump. We're saying, well, if when we rise by 1, we have to run 4. If I ran 3, that means I couldn't rise the whole 4. And sure, you can mentally figure it out that way, but it's a lot easier if you just set up the proportions. All right, moving on. Couple things to remember is when you're doing parallel, parallel means same slope. Perpendicular means negative reciprocal slope. Parallel means same slope. So that's why if you're checking colinear, don't just check AB slope at equals slope of BC. Because sometimes what could happen is you could have something like this. So this would be something like 2. This slope would be something like 2, and you can get a false positive. So what you have to do instead is you have to also check between you have to check this over here, and the way you do that is you check this slope over here. If AC, slope of AC does not fit, then it does not work. So you have to check all 3. So please be careful for that. When you're checking colinears, you have to check AB, BC. So you have to say check part, as well as the 2 endpoints as well. Okay, so with that in mind, parallel just means same slope. Perpendicular means negative reciprocal slope. All right, now this is where it gets a little more fun. One thing that you can do with coordinate geometry and slopes in particular is slopes can give you proportion problems. And whenever you're dealing with proportion problems, you could be working with similar triangles. So let's imagine I give you something like this. And let me get my face out of the way. And I'm asking you to solve for x. You could actually solve for x, assuming these are right triangles, which I should have labeled earlier. And the way you solve for x is you use SOHCAHTOA. In this case, you're going to say tangent inverse of square root 3 over 1 is equal to x. Because what we know is if I take tangent inverse, it says give me the ratio and I'll find you the slope. You plug that into your equation and then you will get you plug that into your calculator and then you'll end up getting a number. In this case, you'll be getting x equals 60. Now, yes, I know that this is not drawn to scale, but you know what? We don't judge on that. Moving on with our lives. Next, if I look at this big shape here as well, I would say tangent inverse of 2 square root 3 divided by 2, because 1 and 2 equals x as well. But if we simplify this, it's just really saying tangent inverse of square root 3 over 1, which we already know is 60. Now, when you have these similar triangles like this, basically what I'm trying to say is, see how there's this common slope here. I rose 3 and I ran 1. I rose 2 square root of 3 and I ran 2, which means my slopes are the same. One thing that you can do is you can use trig to kind of find the degrees, and using those angles you can actually figure out what your slopes are in a slightly more roundabout way. So I'm going to leave it at that. There is a problem like this. I want to see if you guys can figure it out, but basically what I'm trying to say is using this ratio of opposite to adjacent and what we know about slopes and distance formula and stuff, you can use your angle and set up a right triangle and use that to help figure out your slope. Okay? Basically, just remember your sine, cosine, tangent problems. As always, if you have any questions, let me know. If not, I'll see you guys later.